Overvoltage on a ship's shore power connection can be a serious problem, leading to equipment damage and potential safety hazards. When the voltage on a 480-volt, three-phase shore power system rises to 492 volts on at least two legs, it indicates a problem that needs immediate attention. Several factors can contribute to this issue, and it's important to systematically investigate each possibility. Firstly, consider the utility provider as a potential source of the problem. The utility grid itself might be experiencing overvoltage issues. It's crucial to contact the utility provider to report the overvoltage and inquire if they are aware of any problems on their end. They can monitor the voltage at their substation and investigate any potential grid-related issues. Secondly, backfeeding from the ship's generators is a common cause of overvoltage. When the ship's generators are running while the shore power is connected, electrical currents can flow back into the shore power grid. This can occur if the ship's generators are not properly synchronized with the shore power or if the load is not appropriately shared between the generators and the shore power. Check if the ship's generators are operating and if they have adequate load. Insufficient load on the ship's generators may cause them to produce excessive voltage, which is then fed back into the shore power system. To mitigate backfeeding, ensure that the ship's generators are properly synchronized and that the load is balanced between the generators and the shore power. In some cases, it may be necessary to disconnect the ship's generators entirely while using shore power to prevent any potential backfeeding issues. Thirdly, transformer imbalances can also lead to overvoltage. The transformers that convert the shore power voltage to the ship's voltage may experience imbalances, resulting in higher voltage on certain phases. Inspect the transformers for any signs of damage, overheating, or improper operation. Verify that the transformers are properly connected and that their tap settings are correct. An incorrect tap setting can cause the output voltage to deviate from the desired level. Use a multimeter to measure the voltage on each phase of the transformer output to identify any imbalances. If you detect a significant voltage difference between phases, it may indicate a transformer problem. Fourthly, faulty equipment connected to the shore power may draw excessive current, leading to voltage instability and overvoltage. Isolate and inspect the equipment to identify the source of the problem. Use a clamp meter to measure the current drawn by each piece of equipment. Compare the measured current to the equipment's nameplate rating to identify any devices that are drawing excessive current. Look for any signs of damage, overheating, or unusual behavior in the equipment. If you identify any faulty equipment, disconnect it from the shore power system and repair or replace it as necessary. To systematically troubleshoot the overvoltage issue, begin by contacting the utility provider to rule out any grid-related problems. Next, coordinate with the ship's crew to investigate the ship's electrical system. Determine if the generators are operating properly and if the loads are balanced. Inspect the ship's electrical system for any faults or abnormalities that could contribute to backfeeding. Check the transformers for any signs of damage or incorrect connections. Verify that the transformers are rated for the required voltage and load. Use a multimeter to measure the voltage on each phase of the transformer output to identify any imbalances. Isolate and test each piece of equipment connected to the shore power to identify any faulty or excessive current drawing devices. Replace or repair any defective equipment as necessary. Regularly inspect and maintain the shore power system to prevent future overvoltage issues. This includes inspecting the transformers, checking the connections, and testing the equipment. Ensure that the ship's crew is properly trained on the operation and maintenance of the shore power system. Also, refer to the Institute of Electrical and Electronics Engineers Guide for measurement of power factor, reactive power, and true power for information on power quality and measurement techniques. Consult the International Electrotechnical Commission Standard 60038 for power transformer specifications and requirements. Adhere to the National Electrical Code Article 250 for grounding requirements to ensure the safety and reliability of the electrical system. By following these steps, you can effectively troubleshoot and resolve overvoltage issues on ship shore power connections, preventing equipment damage and ensuring the safe and reliable operation of the electrical system. It's important to note that working with electrical systems can be dangerous, and it's always best to consult with a qualified electrician or electrical engineer if you're not comfortable performing the troubleshooting steps yourself. Always prioritize safety and follow proper electrical safety procedures when working with electrical equipment. To elaborate further, consider the following points related to each potential cause. Firstly, the utility provider. If the utility provider confirms that they are experiencing overvoltage issues on their grid, then the problem is likely external to the ship's electrical system. In this case, there may be little you can do to directly resolve the issue, but it's important to document the overvoltage events and inform the utility provider of any equipment damage that occurs. The utility provider may need to take steps to regulate the voltage on their grid to prevent further problems. Secondly, regarding backfeeding, to further investigate backfeeding from the ship's generators, you can perform a load study to determine the actual load on the generators and the shore power connection. A load study involves measuring the current and voltage on each phase of the generators and the shore power connection over a period of time. This data can then be analyzed to determine if there is any reverse power flow from the ship to the shore power grid. If reverse power flow is detected, it confirms that backfeeding is occurring. In addition to load balancing, consider using automatic transfer switches to prevent backfeeding. An automatic transfer switch can automatically disconnect the ship's generators from the shore power connection when shore power is available, and vice versa. This ensures that the generators and the shore power are never connected at the same time, preventing any potential backfeeding issues. Thirdly, addressing transformer imbalances. It's important to use a high-quality multimeter to accurately measure the voltage on each phase of the transformer output. Ensure that the multimeter is properly calibrated and that you are using the correct voltage range. When inspecting the transformers, look for any signs of physical damage, such as cracked insulators, oil leaks, or corrosion. These signs can indicate a transformer problem that could be contributing to the overvoltage. You can also perform a transformer turns ratio test to verify that the transformer windings are intact and that the turns ratio is correct. A faulty turns ratio can cause the output voltage to be higher than expected. If you suspect that a transformer is faulty, it's best to have it inspected by a qualified transformer technician. Fourthly, examining faulty equipment. When isolating and testing equipment, start by disconnecting the equipment from the shore power system. Then, use a multimeter to measure the resistance of the equipment's windings or circuits. A low resistance value can indicate a short circuit or other fault that could be causing excessive current draw. You can also use an insulation resistance tester to measure the insulation resistance of the equipment's windings. A low insulation resistance value can indicate that the insulation is breaking down, which could lead to ground fault and excessive current draw. If you identify any faulty equipment, repair or replace it as necessary. Ensure that any replacement equipment is properly rated for the voltage and current requirements of the shore power system. Additionally, consider installing surge protection devices to protect equipment from voltage spikes and surges. Surge protection devices can help to prevent damage to equipment caused by overvoltage conditions. Some additional recommendations include implementing a voltage monitoring system to continuously monitor the voltage in the shore power connection. This system can provide an early warning of overvoltage conditions, allowing you to take corrective action before any equipment damage occurs. The voltage monitoring system should be equipped with alarms that will alert you when the voltage exceeds a predetermined threshold. Establish a regular maintenance schedule for the shore power system. This schedule should include inspecting the transformers, checking the connections, testing the equipment, and calibrating the voltage monitoring system. Regular maintenance can help to prevent overvoltage issues and ensure the safe and reliable operation of the shore power system. Keep detailed records of all inspections, maintenance, and repairs performed on the shore power system. These records can be helpful in troubleshooting future problems and identifying any trends or patterns that could indicate potential issues. To further elaborate on the inspection of ship's electrical system, the inspection should include checking the grounding system. Proper grounding is essential for preventing overvoltage and ensuring the safety of the electrical system. Verify that the grounding conductors are properly sized and connected. Look for any signs of corrosion or damage to the grounding conductors. If the grounding system is not properly installed or maintained, it can lead to voltage fluctuations and overvoltage conditions. Also check the wiring and connections throughout the ship's electrical system. Look for any loose connections, frayed wires, or damaged insulation. These issues can cause voltage drops and overvoltage conditions. Tighten any loose connections and replace any damaged wiring or insulation. Ensure that all wiring and connections are properly rated for the voltage and current requirements of the system. Furthermore, consider the power factor. A low power factor can cause voltage drops and overvoltage conditions. Improve the power factor by installing power factor correction capacitors. Power factor correction capacitors can help to reduce the amount of reactive power in the system, which can improve the voltage and reduce the risk of overvoltage. Regularly monitor the power factor and take corrective action if it falls below a certain threshold. Also, ensure that the shore power cable is properly sized for the load. An undersized shore power cable can cause voltage drops and overvoltage conditions. Use a cable that is rated for the voltage and current requirements of the system. Inspect the shore power cable regularly for any signs of damage or wear. Replace the cable if it is damaged or worn. These added steps provide a more thorough approach to identifying and resolving overvoltage issues on ship shore power connections. Remember, safety is always the priority.